Hi, it's Mr. Doro. Today we're going to be talking about acid-base theories and the reactions that they go through. And by the end of this, I would hope that you could define and recognize the different types of acids and bases and distinguish between them. We've already talked about Arrhenius acids and bases, and an Arrhenius acid is something that produces protons in water. Remember that protons are hydrogen ions, H+, or they could be hydronium ions. All three of those are synonymous with each other. And if you look at this picture right up here above, you have HCl, which we know is hydrochloric acid, and reacts with water, and it's going to make H3O plus and Cl minus. If you look at the process here, then you can see that the hydrogen atom and the chlorine atom broke apart, and this is a before picture, this is an after picture. The chloride is all by itself here on the end, and then the hydrogen joined up with this water to make the hydronium ion. An Arrhenius base produces hydroxide ions in water. So we've got NH3, which is ammonia, reacts with water, and in this case the water breaks up and one of the hydrogens goes over here and joins up with the NH3 to make the ammonium ion and the hydroxide ion. And so this would be an Arrhenius base right here. This would be an Arrhenius acid by definition. Well, the Arrhenius definition worked pretty well for acids and bases, but scientists then found out that they had some things that acted like acids and bases that were not in water solutions, and so they had to come up with an expanded definition for acids and bases. And so two chemists got together, and their names were Bronsted and Lowry, and came up with the Bronsted-Lowry definition for acids and bases. And those are going to show up in just a moment. And here they are, very abbreviated definitions. This is Bronsted-Lowry, BL. Bronsted-Lowry acid is a substance that will donate a proton. Remember what a proton is? A proton is a hydrogen ion. And a Bronsted-Lowry base is a proton acceptor. Now this is tricky here, and you got to watch this. Look at down here. We've got these labeled as acid and base according to Bronsted and Lowry. And so if you look at which way the hydrogen ions are going, remember this is before the reaction. This is after the reaction. So we're kind of looking at a before and after picture. We started out with this one had HCl. Over on the other side, you can see that it just turned into Cl minus. Now what happened? It got rid of a hydrogen or a proton. And so where did it get rid of it? It gave it to this H2O, which ended up being H3O plus, 3 hydrogens. And so what you have to do is look at before and after. You see that this one got rid of a proton. It donated it to the water right here. And so since this was the proton donor before and after, it got rid of a proton, donated it, then that makes it a Bronsted-Lowry acid. So this would be an acid right here. This one right here accepted the proton. You can see the protons going from the HCl to the H2O. That would make it a proton acceptor, and that would make it a Bronsted-Lowry base. So we're looking at before and after. What happened to it? This got rid of a proton. This one accepted a proton. That's the definitions for Bronsted-Lowry acids and bases. There's another definition that is even broader for acids and bases, and this one doesn't even have to have anything with hydrogen in it. And so it is a Lewis acid is an electron pair acceptor, and a Lewis base is an electron pair donor. I just want you guys to know that those do exist, and we won't be using them in this class, so you don't even have to worry about it. When we're dealing with Bronsted-Lowry acids and bases, we're also going to have conjugate acids and bases. Conjugate acids and bases are always going to be on the right side of the arrows. And when you see this arrows, this double arrow like we have right here, that means that these two reactants will react with each other to produce these two products. But then these two products could react with each other to go back and form these two reactants until they reach a state of equilibrium where that is happening at a constant rate. Now, these on this side, the right side of the arrow, are going to be conjugate acids or bases. Here's what you got to know. For each base that we have on this side, and we know it's a base because it accepts a proton, and we can see going from NH3 to NH4, it has accepted a proton. Each base will have its conjugate acid, because if we look over on this side, when these react with each other to go back and form this, the hydrogen comes from the NH4 and goes to the OH to make this H2O. So that makes this an acid now because it is donating a proton. So for each base, we'll have a conjugate acid. For each acid, we'll have a conjugate base. If you look down here on this one, we have hydrochloric acid, and we go over here, we look, it made the chloride ion because it donated the hydrogen to the H2O. That makes it an acid. But then when this chloride ion reacts with the hydronium ion, H3O+, then it will then accept a proton from the H3O+ to go back and form HCl, which makes it a conjugate base on this side because it is accepting. There are some substances that are called amphoteric compounds, and they could act as either an acid or a base depending on the acidity of the substance that they're reacting with. Now, this is going to be surprising to some of you, but water, H2O, could act as either a Bronsted-Lowry acid or a Bronsted-Lowry base. We wouldn't call water acidic, but it acts like it because it can either donate a proton or it can accept a proton. Now, if it's reacting with something that's more acidic than water, then it'll act as a base. If it is reacting with something that's more basic than water, it will act as an acid. The reaction that we have down here in the bottom is called autoionization of water, and this is where two water molecules will react with each other and they'll break apart, and one of the hydrogens will go over and join the other water, and so you'll actually make hydroxide ions and hydronium ions. So one of these would end up being a donor or an acid according to Bronsted-Lowry, and the other one would end up being a base. That's weird to think about that one could be an acid and one is a base, but remember, it's the reaction that they're going through. It doesn't mean the pH is changing or anything like that. It's just the reaction that they're going through to make those products. An acid and a base will react with each other to neutralize each other, to make a salt and water. We learned this before when we did reaction types about acid-base neutralization, but now we have a little better understanding of it. So this is a strong acid, nitric acid, and a strong base, sodium hydroxide. They'll react together to make this salt, which is not the salt you put on your French fries. It is just, and salt is a generic term for an ionic compound, and water. Now, we can have an understanding of how this works now since we have a better understanding of solutions. So when we have this strong acid, nitric acid, it will ionize to make hydronium ions and the nitrate ions. And we have the strong base will ionize completely in water to make sodium ions and hydroxide ions. Now all of these, when they're mixed together, will react with each other to make this. This is called a net ionic equation. And so really, you have NO3 minuses, nitrate ions, on both sides, and sodium ions on both sides of the arrow. Those are called spectator ions, and since they're dissolved in water on each side, then they really don't take part in the reaction. The only reaction that you have is the hydronium ion and the hydroxide ion reacting to produce H2O. So overall, this is what you end up getting. You get H3O plus OH minus produces H2O. Now we write it as salt and water because if you were to boil this water off of there, then these two would join together to make sodium nitrate. And so this is the reaction that you really end up getting no matter what you have. If you have a strong acid and a strong base, you end up getting water and the salt, whatever the salt is. Okay, so on your notes then, I'd like you to write out these four different reactions. For each one of them, I want you to identify the Bronsted-Lowry acid. You could just put BLA, and the Bronsted-Lowry base, BLB, and the conjugate acid, you could just put CA, and the conjugate base for each of the following. And all of these would have a Bronsted-Lowry acid, a Bronsted-Lowry base, conjugate acid, conjugate base. Look back at the instructions to see if you can't remember or look at your notes if you can't remember what the definition for each is. Thanks. Have a good night.